But first, can anybody figure out what would go in the blanks here? In a, what kind of triangle? In a right triangle. So the Pythagorean theorem only works in a right triangle. You can't use it for obtuse or acute. So in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two legs. Alright, and we usually represent this formula as a squared plus b squared equals c squared. Now it's very important for the Pythagorean theorem that you know which letters represent what. So notice how I have the c on the hypotenuse. It's very important that you remember that the c squared on the right hand side of the equation is always the hypotenuse squared. Something that's easy to forget depending on where the variable is in the question that we're going to be solving. So remember that the a and the b, the two legs that you're squaring and adding together, those are on one side of the equation and the hypotenuse squared is on the other. So please make sure you remember to write the equation. Now, this proof right here is the only proof in this entire unit. Okay? We are giving up proofs for this unit in exchange for higher level thinking strategy questions that have to use the calculations and formulas that we're learning in this unit. So I don't know how much of a switch off that is. You guys will have to figure that out as we approach those questions. But yeah, we're switching off from proofs to look at slightly more complicated solving questions. But just to go through this one relatively quickly, it's taking the ideas that we learned last unit with similarity and showing why the Pythagorean theorem works. So we can take that connection and see how it works. So just really quickly, go ahead and write the givens for me. We're going to write one of each in separate lines just because they're a little long. So the first one, we have that ABC is a right triangle, and then we have that CD is an altitude. Those are givens. Alright, so we're going to be using similarity and the geometric mean to prove that a squared plus b squared equals c squared. Alright? So think back to what we were doing last unit. If I know that this full triangle is a right triangle and this is an altitude, does that look familiar for things that we've learned how to solve? What kind of rules did we learn for that scenario? Let's say I asked you guys to solve for the altitude. What method would you use? You guys remember? The splash mountain and the roller coaster rules. Those apply in this scenario. So we're actually going to be using those ideas to help us with this proof. Right here. Alright, so we're going to be taking that idea to help us. So if we know that this is a right triangle and this is an altitude, you guys remember what the right triangle altitude theorem says? I know we didn't really talk about the name very much, but do you remember the very first thing that we learned when we saw this picture? What does the altitude do to the big triangle? Splits it into two new ones. What do you know about the two new triangles and the full triangle? What's the relationship? They're all similar. So that would be the next thing that you guys would write down. I know that the full triangle is similar to the small one and the medium one, the ones that are broken up by using the altitude, and that's what we learned last time with the right triangle altitude theorem. If you draw that altitude, you get these relationships. I was just asking before, the roller coaster rule and splash mountain, you can only use those rules once you've established that the triangles are similar using that right triangle altitude theorem. So what we're going to do next is, because we're trying to work with a squared plus b squared equals c squared, I need to start bringing those variables in, specifically the b and the a. So do you guys notice how I don't have anything on the altitude? It's not labeled. So which of the two rules would I use, splash mountain or roller coaster? I would be using the roller coaster rule. So we're going to do it twice. We're going to do roller coaster rule for this leg, and then we're going to do roller coaster rule for this leg. Okay? So what would my roller coaster proportion look like if I started with B? It would be what?
C
Equals
B
over E. So if you guys use the roller coaster rule, you would get C over B equals B over E. I had to write it with the slashes because I couldn't type it in very well. So just write it as a fractions so you guys can see it a little bit better. You can write it like that. Just with my keyboard, I couldn't write it with that format. Alright, so that's using the geometric mean. The roller coaster rule is technically a geometric mean question, so we get to write that. Now, what did we usually do after we wrote a proportion? Cross multiply. So your next step is going to be what that looks like as a cross multiplication, because notice that when you cross multiply, that's how you get the b squared for the Pythagorean theorem. So we don't want to leave the fractions. We're going to go ahead and cross multiply so I get the b squared. So that's this part. You got that. How do I get the a squared part? Can I do the roller coaster rule the other way? What would the roller coaster rule be for if I used leg A? Yes, it would be C over A equals A over D. Using that same geometric. C over A equals A over D. And again, that's using the roller coaster rule, which is technically finding the geometric mean. Now we want to manipulate this to get the a squared to show up, so what would I do? Just multiply again, just like we did for the other one. So that would give you your a squared equals c times d. Using cross multiply. Okay. Now, what do you guys think I would do? I have the a squared and the b squared part. What do you think I would do now? They're separate right now. How can I get it to look more like the Pythagorean theorem? What do I do with the a squared and the b squared? Look at the theorem. What do I do with the a squared and the b squared? You add them together, so that's going to be our next step. I'm going to define what a squared plus b squared is using these expressions. So this is the addition property. Because I know that b squared and c times e are the same value, I can add 1 to either side of the equation and maintain equality. So I took this equation right here, I added b squared on one side and c times e on the other side, and it maintained equality. So now I have a squared plus b squared, the first half of my Pythagorean theorem, but that's equal to c times d equals c times e. So how can I get this somehow to turn into c squared? What algebraic properties can I do? This is no longer geometry, this is algebra. How can I manipulate this? What's something I could do with this? I have c times d plus c times e. Common what? It's called a GCF. Greatest common factor. I'm going to be factoring. So they both have a c in common. So I'm going to factor this. Because they both have a c, I'm going to pull the c out of the expression. It's like undoing the distributive property. That's basically what factoring is in this instance with the GCF. So I'm undistributing the c, so I can get c kind of isolated there. Now I have c times the expression d plus e. Well, if you guys look really quickly back up at the picture, which I can't see on my screen, but you guys have on your page, what is d plus e? That is c, right? So before you notice that d and e is equal to c. You can't just automatically plug that in. Remember, you guys have to define that for me. Remember, anytime you guys notice that 2 parts equals a whole, you do have to use the segment addition postulate to define that within a proof. So I'm going to really quickly say that d plus e is equal to c, which I noticed in the picture. And then how can I wrap up my proof? If I know that d plus e is equal to c, I can use substitution to replace the d plus e with a c, and c times c is really c squared. So that gets you your a squared plus b squared equals c squared. So there are other ways to prove the Pythagorean theorem, but I thought this one was cool because it connects your information from last unit to show how you can use that as an application here with our new information. Alright, so that's really the only proof we're going to be doing in this unit, just to check that out. Alright, let's see how the Pythagorean theorem works, actually using it. right? So the best way to approach this, because you have to remember that A, B, and C are all different sides. The most important side to remember which is C. So in this scenario, what would represent C? Would it be the 6, the 10, or the x? With the x, you have to remember that the hypotenuse is always C, alright? So these two are A. It doesn't matter which one's A, which one's B, because you're just adding them anyway. So I'm going to do 6 squared plus 10 squared equals x squared. This is how you use the Pythagorean theorem. You take the A, B, and the C, and you plug them in. Then you just evaluate. So 6 squared is 36, 10 squared is 100, so 136. Trying to solve for x. How would I move from here? You take the square root. Now remember, anytime you guys are working with square roots, you always have to simplify it. You may not give me the answer as a decimal. We're using the most accurate, say again? 4 and 34. Can you split 34 any further into perfect squares? No, this is 2 and 17, which are both prime. Therefore, 4 is the biggest perfect square. So how would I simplify that square root? 2 square root 34. That should not have taken it for you guys. Alright, for the next one. Which one's C for the Pythagorean theorem? 3 square root 2. So that means you're going to take the other two sides, you're going to square them and add them together. So x squared plus 4 squared equals 3 square root 2 squared. The variable does not always have to be C. Variable could be anywhere. That's why you guys have to make sure that you're careful with what value is C and which one's not. So in this one, we're just going to square everything. So x squared plus 16. Now, do you guys know how to square a number like that? You guys ever seen anything like that? There are two parts to it. So when you guys have a number like this, the 3 is being multiplied times the square root of 2, but it's still one expression or one number. So what you guys need to do is square both parts. So we're going to square, it's kind of like a distribution. Right, you're only allowed to distribute powers when it's a monomial. So for this number right here, you're going to square the 3, and then you're going to square the square root of 2. So what happens when you square 3? 9. Remember, this is multiplication. And then what happens when you square the square root of 2? You guys remember the relationship between squares and square roots? What do those do to each other? They cancel. A square and a square root are inverses. They cancel each other out just like addition and subtraction cancel, or multiplication and division cancel. So when you guys are squaring a square root, both of those two things go away. So what would be left behind? Just the 2. The square and the square root cancel, leaving just the number inside behind. It's the only. They just cancel each other out when you guys are working with those symbols. Alright, so what's 9 times 2? 18. So now we have this. What would I do next? Move the 16 over. Then square root. Can I simplify the square root of 2? No, 2 is it. Alright, next one. Which one would be C in my Pythagorean theorem? Would be the square root of 20, square root of 5, or x? X. The one on the hypotenuse is always the c squared, so you would square the other ones on one side, add them together, and set that equal to c squared. Alright, now, just like we were talking about, if I had the square root of 5 squared, what would be the result of just that? Just 5. The symbols cancel each other because they're inverses. And then if I have the square root of 20 squared, which is 20. Just leaves the number on the inside behind. So those two numbers, when you add them together, is 25. So I have 25 is equal to x squared. So what would the value of x be? 5. Alright, so this is how we use the Pythagorean theorem. You just have to remember the properties of squares, like square roots. When you're squaring them, you have to remember how to work with those. So just be careful with that. Alright, taking up a notch just a little bit. So here we have, what kind of triangle would that be, the full one? Oh, more than that. It's equilateral. So this angle is equal to this one is equal to this one. So all of the sides are the same. That's something you need to notice first. So this is an equilateral triangle. But something that we haven't specifically talked about before, but I want to just let you guys know now. In an isosceles or an equilateral triangle, if you guys draw an altitude, which is what I've done here, remember an altitude is when you drop from a vertex, so it's perpendicular to the opposite side. If you guys draw an altitude in an isosceles or equilateral triangle, it actually splits that side in half. That's something that will come in handy, so you can write that down. An isosceles or equilateral triangle, altitude bisects side in a very abbreviated format there. And that will always be true. So if you notice that the sides are equal or the angles are equal and you have that relationship, the altitude will split that side that it's touching in half. So that means that these are both 8. Alright, that was important because when you guys are solving for Pythagorean theorem, you need at least 2 numbers and you're trying to solve for the third side. So in order to solve within this right triangle, which is just half, right there, I needed to know this side, something here, and something there. So that's why that rule came in handy so we could find that 8. So how would I write the Pythagorean theorem for this to solve for x? Anybody know what the formula would look like? X squared plus equals, yes. Just make sure everything's in the right spot. The 16 being the c because it's hypotenuse. And then you would 16 squared minus 64. You do 16 squared minus 8 squared because you need to get them on the same side. You get 192. Take the square root of that. You guys will need to simplify. So again, you guys need to find 2 factors where one is the biggest perfect square. Take a little bit of exploration. And 3. So 64 is a perfect square, which square roots to 8, leaving the 3 behind as the factor inside the rack. Okay? Now, using this idea again, we're going to try to find the area of this triangle. Do you guys remember what the formula is for the area of a triangle? Some of you guys on that bonus question do. What is it? Almost. It's 1/2 base times height. Did you say base times height divided by 2? Okay, I didn't hear the second half. Sorry. So, first we need to find out what the base and the height are so we can actually plug them into this formula. So, what's the base? 10, right? What's the height? Do we know it? No. Remember the height for a triangle has to be straight up and down, which is this part right here. So, in order to find that height, we have to use the Pythagorean theorem. And remember, this is an isosceles triangle with the altitude drawn, so what does that do to this? It splits it in half, just that we're using the same rule over here. It works for both isosceles and equilateral. So if these are both the same, then it splits this side in half, so we have 5 and 5. I'm trying to find the height so I can actually plug that into the area here. So how would I find the height? It's a right triangle. I have 2 of the 3 sides and I'm looking for the third one. That's your scenario for Pythagorean theorem. And you know 2 of the sides, you're looking for the third one. So what would my formula look like? Anybody? Just put your numbers in. What would the formula look like? H squared plus equals. Yes. Make sure you remember which one's A, B, and C and where you put them in the formula. And then you would solve that. So you'd have 64 minus 25. So it gets you 39. Again, you want to leave that as a square root for now. Don't try to turn it into a decimal or anything. Alright, was that what the question was ultimately asking for though? Were they just looking for the height? No, they wanted to know what the area was. So now we're going to plug that into the formula. So 1/2, what did you guys say the base was? 10. They want the full base, the full length of that bottom side, times the height, which we said was square root of 39. So just one small change that I would make, so this would be fully simplified. How would I write that? What are the two numbers in there that I could actually multiply easily? The 1/2 and the 10. So if I multiply those together, what do I get? 5. So your answer would just be 5 squared root 39. Sorry. Don't try to multiply the 10 and the 39 by 1/2. Alright, those are all three numbers being multiplied. So since those are the rational numbers, you can just multiply those together and do the irrational number, the square root of 39. Alright, I'm going to let you guys figure out that one on the far right yourself. See if you can figure that out. Again, it is a Pythagorean theorem question because you guys have you have all three sides labeled, but you have enough information to actually use the Pythagorean theorem in this one, even though two of the sides are variables. So I want to see if you guys can figure that one out on your own, and then we'll talk about it in a second after you've given it a shot. You guys get that? 2 square root of 6, which would have started as square root of 24. Yes? So hopefully when you guys wrote the formula, started as that. Right? Since there are two of these, obviously they combine. You distribute the square like we did before. Right? The 4 gets squared into 16. The square root of 3 gets squared into just 3. The symbols cancel each other. You have to make, this is 48, so when you divide by 2, you get 24. Please remember in the step of algebra, or the solving process, when you guys are taking a square root, you have to get rid of the coefficient first. That's often a mistake that I see, is when you're here, you automatically go into the square root of 48 and then divide by 2. Don't do that. Only ever square when the variable's by itself. So you divide by 2, you get the square root of 24. That simplifies to 2 squared 6. Alright? Any questions on the kind of basic application of Pythagorean theorem? Okay? We're also going to be seeing some applications of quote-unquote real-life problems or word problems that you would see here. Again, the scenario in which you guys will be using the Pythagorean theorem is when you guys don't know any angles. You really don't know anything about the angles in these triangles except for the fact it's a right triangle. But they've given you something for all three sides and you're trying to find one of them. So you just have to draw a picture for yourself, label it, and then see how to use Pythagorean theorem. So this one says that the legs of an isosceles right triangle, so I'm going to start with that. Alright, so right triangle is isosceles, which means the two legs are the same length. It says that the legs of that triangle are 6 units long, so both of them are 6. I want to find the length of the hypotenuse, which I'm going to label with an x. So using the word problem, you can create the diagram for yourself, and then this is just another Pythagorean theorem, again, because you have something for all three sides, but you're trying to find the third one. Alright, so how would I write the theorem? Okay. So that's 2 6 squared, so it's 36 twice, which would be 72. I'm going to take the square root of that, and then if I can, I would simplify that as well. It should be 36 times 2. 72 is the same thing as 36 times 2. 36 is the biggest perfect square, so it should simplify to 6 square root of 2. Alright, this next one right here. So somebody is setting up an underground sprinkler system as shown below. We want to know how many total feet of water pipe will she need. And so notice how they have 3 arrows. You can see they have this, this, and this. The key word in this question is total. They have 3 arrows pointing to 3 different sections. That means that we're going to be adding all 3. That's something that this is actually really close to a lot of SOL questions that they might give you, where they're asking for all 3. I have 2 of them. It's the third one that I really need to find here. So the gotcha answer that they'll put on the SOL is whatever the length is for this. Because you guys will be doing the question, you'll see that you have to do Pythagorean theorem, you'll do Pythagorean theorem, get this answer, see it in the answer choices, choose it, move on. But is that what the question is asking? No, they wanted the total. So you guys have to make sure that you understand what the question is asking and remind yourself that before you choose an answer and move on. So yes, we do have to find this right here. So I'm going to I can't remember if I fixed this before or after I printed the notes, but I added a little note saying that her yard is rectangular. It's kind of important because we need it to be a right triangle. So you can go ahead and add that detail. So we know 2 of the pipes, we don't know this kind of diagonal one, so I need to find that. So how would I do that? Here. Obviously I'm trying to find this, which is x. Do I have all 3 sides of the triangle labeled? I need that though, so what do? Okay, so hopefully you guys remember the property of a rectangle that the opposite sides are equal. Okay, so if this is 56, I can move 56 over here. So now I can use this information to help me solve for that 3rd line of pipe. So I'm going to use Pythagorean theorem. 56 squared plus 85 squared is equal to x squared. Now, when the numbers are this big and it's a word problem, this is the only scenario where you guys are allowed to use decimals. If the numbers are reasonable and you can simplify to use a radical, I expect you to do that. But if the numbers are ginormous like this, and it would be super hard to simplify a radical, and it's a word problem, you guys can use decimals. So just go ahead and figure out what this number is, do 56 squared plus 85 squared, and then take the square root of that. Tell me what that is as a decimal. Are big, hard to simplify those radicals, and it's in the context of a word problem, you are allowed to use a decimal. So now, you might see in the answer choices 101.8, but you wouldn't choose that because they weren't asking for just this pipeline, they were asking for the total. So now I have to take this slanted one, add it on to the vertical and the horizontal. So you're going to do 101.8 plus 56 plus 85. What would be your grand sum of all of that? Hopefully, you get that. Yes? Okay. So again, that's a tricky one. You have to make sure that you're reading the question carefully so you don't accidentally miss what the question was really asking. Alright, I'm going to see if you guys can do the next 2 on your own, this one and this one. Draw a picture for yourself. Hopefully you guys can, north, west, or northeast, southwest, you guys can see that kind of in your head when you're working with the directions for that one. Save this one, we'll work on this one together, but I want you guys to try those 2 on your own. See if you can draw the picture and then use Pythagorean theorem to solve. Can I use Pythagorean theorem in this triangle first? Okay, so let's say our goal was to find this side before we find that one, right? You can do Pythagorean theorem really quickly. 4 squared plus 2 squared is equal to x squared, right? So 16 plus 4 is 20, right? Obviously you don't want to write the square root of 20 because it's not simplified. But if you guys were to simplify the square root of 20, which you would get as a result from this, what would that be simplified? 2 square root 5, right? So now you do have that side that you needed to finish Pythagorean theorem for the bigger triangle. So we're going to say this is our new variable here. I'm going to call it y just so it's different from the x we used before. So if I was doing Pythagorean theorem, right, it would be 2 square root 5 squared plus square root of 80 squared equals y squared or ab squared, whatever kind of variable situation you want to work with. How would I continue with this one? Remember, what do you do with this? Distribute, so it's really 4 times the 2 gets squared into a 4, so it's 4 times 5, which is 20. And then what happens to the square root of 80? Yeah, the symbols cancel each other, which is just leaves the 80. That's 100. What's the square root of 100? 10. So your ultimate answer for AB would just be 10. Okay? Questions on how I approach that? So those kinds of questions where you guys have to notice that something's missing and figure out how to get that, that's a lot of what we're going to be working on in this unit. Alright. 2 more quick concepts to wrap up with the Pythagorean theorem. So there are things called Pythagorean triples. So the Pythagorean theorem, the a squared plus b squared equals c squared. When we were working with many of the examples we were just seeing, the answers were radicals, or something that would turn to a decimal. Pythagorean triples are sets of numbers that actually are all whole numbers that work for the Pythagorean theorem. So it means that you could plug in these 3 numbers into A, B, and C, and it would work for the Pythagorean theorem perfectly, or satisfies the Pythagorean theorem. So there are 2 that I want you guys to memorize, right? Because when you have access to those 2, it actually helps kind of unlock doors into shortcuts you can use for certain questions and things like that. So the Pythagorean theorems I want you guys to memorize are 3, 4, 5. Not that hard to remember. And then 5, 12, 13. As well as any multiples of those 3 numbers. So if a Pythagorean theorem triplet is 3, 4, 5, you could also multiply those numbers by 2 and it would still work, 6, 8, 10. Okay? So these 2 sets of numbers and their multiples, those are always going to work for the Pythagorean theorem. Now when you guys look at these right here, you need to be able to tell which one's A, B, and C, or really C specifically. If I looked at 3, 4, 5, which one would have to be C? Why? Because it's the piece in your right triangle. So that's something you guys also have to remember. Because like we're going to see in this question right here, I'm going to ask you if it's a Pythagorean Pythagorean triple or not. What you're going to do to check to see if it's a Pythagorean triple is plug into Pythagorean theorem and see if it works. If you can take those 3 numbers and plug them into the Pythagorean theorem and it works out, that means it was a Pythagorean triple to begin with. So if you check really quickly with a 3, 4, 5, just to prove why it's a Pythagorean triple, if you do 3 squared plus 4 squared, 3 squared is 9, 4 squared is 16, with 9 plus 16. 25. Is that the same thing as 5 squared? Yes. So that's how a Pythagorean triple works. It's just 3 sets of numbers that will always work when you plug them into the Pythagorean theorem. If you guys are trying to generate Pythagorean triples for yourself, this is the formula. Whatever m has to be less than n when you're working with these formulas, but if you're trying to generate one for yourself, if you pick 2 numbers m and n and plug them into these formulas, that will help you find A, B, and C. So in case somebody asks you to generate a Pythagorean triple, that's how you do it. You don't have to memorize that per se, but that's something interesting to know and be able to use. So, question here. Would these 3 numbers be a Pythagorean triple? How would I check? Plug into the Pythagorean theorem. Carefully. Which one should be C? You have to make sure that the biggest one is reserved for the C squared. So I'm going to do 45 squared plus 28 squared, and I want to see if that's equal to 53 squared. If it is, that means a Pythagorean triple. If it's not, that means it was not a Pythagorean triple. So that's big numbers, right? So 45 squared plus 28 squared is that number. Hopefully you guys found that in your calculator. Then what would 53 squared be? It should be the same number. Yes? Everybody get that conclusion? So if this side of the equation is equal to that side of the equation, would that be a Pythagorean triple? Yes. Okay? Now we're going to check this one. Which one of these numbers would be C? Which one's biggest? It would actually be 8. Well, actually, check square root of 24 for me really quick. Yeah, so square root of 24 is less than 8, right? So I will want to use 8 as my C. So it gets a little bit choppy when you guys see square roots because you see the 24 and you want 24 to be bigger than 8, right? But it's not 24, it's the square root of 24. So always double check to see what these actual values are before you move forward. So I'm going to do square root of 24 squared plus square root of 18 squared, and then check to see if that's the same as 8 squared. So obviously the square roots on the left-hand side cancel away, so you just have 24 plus 18, which would be 42. And then what's a squared? 64. Are those two the same number? No. So would that have been a Pythagorean triple? No. Okay, so they ask you to check if something is a Pythagorean triple. All you have to do is check to see if it works in the Pythagorean theorem. Alright, last concept for today, the converse of the Pythagorean theorem. The converse. Do you guys remember what that is? What's a converse? What do you do to write a converse of something? Switch the order, right? So that's all that this really is. If you guys think back to, or even flip back to look, the order of the ideas for the Pythagorean theorem started with if a triangle is a right triangle, then a squared plus b squared equals c squared works, right? We're going to switch that order now. Now we're going to say if the square of the longest side of the triangle is equal to the sum of the squares of the other side, so if a squared plus b squared equals c squared, then the triangle is a right triangle. So it's taking those two ideas, the if and the then, and it's switching them, the hypothesis and conclusion switch. So now the way that you use the converse of the Pythagorean theorem is to check to see if a triangle is a right triangle or not. Okay? And then we're going to see a little bit of an extension there. If it's not a right triangle, then what kind of triangle is it? Is it acute or obtuse? We're going to see that with these rules right here in a second. But first, the most straightforward application of this is by looking at these triangles. Notice I don't have the little right angle box thing. I want to know if they're right triangles or not. How do I do that? Plug into... Okay, we're going to plug this into the Pythagorean theorem, but you have to do so carefully. How would I write it for this example right here? Why did you write it in that order? Does it have to be in a particular order, or can I just put the numbers anywhere? It has to be in a particular order. I know it's not a right triangle right now, we don't know that, so I can't call this a hypotenuse. That's why I use the terminology longest side instead of hypotenuse, because I don't know if it's actually a right triangle or not. So, but you still have to remember that the longest side, whether it's a right triangle or not, has to go in the c squared position. Okay? So now I have 9 squared plus 10 squared. What would that be as a sum? 100 plus 81. And what's the square of 11? Are those the same? So would this have been a right triangle? This would not have been a right triangle. This is the exact same process as checking if it's a Pythagorean triple. It's just worded differently. It's a different context. So if the two values do not work, that means this was not a Pythagorean triple, which means it's not a right triangle. Okay? What about over here? Which one would I treat as C when I'm checking the Pythagorean theorem? Which one of those sides is the biggest? 8 squared root 2 is going to serve as my longest side. I don't know if it's a hypotenuse per se, because we don't know what kind of triangle it is. But I'm going to use that as C. So I have 8 squared plus 8 squared. Is that equal to 8 square root of 2 squared? Right? So on this side, I have 8 squared twice, which would be 64 times 2. 128. You guys do that distribution, right? You would have the 8 is squared, which becomes a 64. Then what happens to the square root of 2? Squared. It's just 2. So what's 64 times 2? 128. So those two values end up being the same. So was this in fact a right triangle? Yes, it was. So again, it's the same idea as checking if it's a Pythagorean triple or not. It's just in the context of checking what kind of triangle. But it's the same process, same idea. Alright, everybody good on how to use converse? Alright, so like for this instance right here, where we said it's not a right triangle. Well, if it's not a right triangle, maybe we want to know what kind of triangle it is. If it's not a right triangle, what is it, acute or obtuse? So I have these little extensions right here. Obviously, if a squared plus b squared equals c squared, then it's what kind of triangle? A right triangle. So we know if they're equal, it's going to be a right triangle. Now we're going to look at these inequalities. If the longest side squared is bigger versus the longest side squared being smaller, that tells you what kind of triangle it is. So I'm focusing on the c squared in all of these rules. You still have to add the squares of the other two sides, but I'm focusing on this. So if it's equal to right triangle, if the c squared is bigger, it's obtuse. That should make sense, right? If the single longest side squared is still bigger than the other two sides added together, it means it was spread out like that. It's a really long side there. But if the c squared is smaller than the sum, that's acute. So focus on the c squared idea. If it's bigger, it's obtuse. If it's smaller, it's acute. Pretty intuitive for that kind of rule. Right, so the main thing I'm going to ask you is I'm going to give you three sides, right? I'm going to ask you what kind of triangle it would create. Well, first I'm going to ask you if it would create a triangle in the first place. That was from last unit, Unit 5. And then once you determine if it's a triangle, I want to know what kind, right? So this is where it gets tricky. Do you guys remember how to decide if a triangle can be made in the first place? You guys remember that process? I give you three sides and I want to know if it's a triangle. Anybody recall? Triangle inequality. 5 sides, 9, 8, and 7, and I want to know if it can make a triangle. Tatum?
7 plus 8 has to be greater than 9.
Yeah. You have to add the two smaller sides, make sure it's bigger than the third side. We learned that in Unit 5. So if I add 7 and 8 together, what do I get? Get 15. So for my first question, would those create a triangle in the first place? Yes. Now this is where it gets tricky. Did I square anything when I was doing that? No. So just checking if it's a triangle in the first place, just generic question like that, you don't square it. But if I follow up and say what kind of triangle it is, that's when you bring the squares in. So you guys have to know the difference between those questions. If you're trying to see what kind of triangle it is, you square. If you're just trying to see if it's a triangle in the first place, you don't. So please make sure you keep those ideas separate. So now that I've determined it's a triangle, I'm going to do the exact same process. I'm going to add the two smaller sides together and compare to the longest side, but I'm going to throw squares in now. So I'm going to do 8 squared plus 7 squared. I'm going to compare that to 9 squared. I'm going to put a little box here. I'm going to fill that box with a equal sign, a greater than sign, or a less than sign. So 8 squared is 64, 7 squared is 49. Add those two together, 113. Alright, what's going on? Is the c squared, the longest side squared, is that greater than, less than, or equal to this number? It's less than. So if the c squared is less than, what kind of triangle? Acute. So that's the full process. It's answering both questions. Is it a triangle in the first place, and then what kind? Questions? Alright, question B. Would those create a triangle? Why? What's equal to? So you take the two smaller sides and add them together. Is it supposed to be equal to the third side? For it to be a triangle, that sum has to be greater than, which is not happening here. So would I say that this is a triangle? No. If I answer no to this question, would I then proceed to figure out whether it's acute, obtuse, or right? No. So I've had people do that in the past, which is very confusing. So when you guys see that it's not a triangle, say no, move on. Okay. Alright, let's just do one more together and then I'll have you finish the rest of them on your own. So this one right here, the 4, 5, and 7. I want to know if it's a triangle in the first place. How would I determine that? The two smaller sides, 9. Is that what I want for it to be a triangle? Yes. So the sum is bigger than the individual sides, so yes, it is a triangle. Now what do I do differently in order to figure out what type of triangle? Now we're going to square them. So 4 squared, 5 squared, compare that to 7 squared. 25 plus 16, 45. Is the c squared bigger than, less than, or equal to? Greater. The 49, the c squared, is greater than the sum of the two sides added together. So what kind of triangle would that make this? Obtuse. Alright, everybody get the gist of that? Alright, have you guys go ahead and wrap up with D, E, and F. This last three. Alright, what did you guys get for D? Is it a triangle? What kind of triangle? Yes. Hopefully everybody got that one. Okay. What about this one? Is it a triangle? Yes, it is a triangle. What kind of triangle is that? It is obtuse. You may need to check really quickly to see what side's biggest. Just evaluate the square root of 5 by putting it in your calculator, see it's a decimal. That can help you evaluate how you want to work with the numbers. That is the smallest number of all of them because it's the square root of 5. But in case you're wondering, like if that was square root of 10 and you're not sure if it's like bigger than 6 or 5, again, you just plug it into your calculator, see what it is as a decimal. And then what about this one? Why not? Alright, so when you add the two smaller sides, they're less than 12, not greater than. Alright, so there are a couple different things that we talked about in this unit, or this lesson. So how to use the Pythagorean theorem to solve, how to use the converse in that idea to check if something is a right triangle or a Pythagorean triple, and then to see what kind of triangle it is if it's not a right triangle. Does anybody have any questions about those concepts? Alright, so we have a bit of class time left. My recommendation is that you work on the graded assignment more, because we're only going to have 1+ period between now and its due date, and our lessons will get increasingly complicated as we go through the unit because of those higher level thinking questions we're going to be doing. So we may not have a whole lot of time in future classes to work on the graded assignment. So my recommendation is if you haven't gotten very far, go ahead and work on it, get a good chunk of it done. But the homework is just one page, one-sided, not double-sided. So you guys can work on that after you've worked on the graded assignment, but I feel like you should be able to do that